In this problem on the topic of dynamics, we want to consider the coefficient of kinetic friction between the mass ma and the plane in the figure is mu k and it's 0.15. The two masses ma and mb in the figure are the same, and that is 2.7 kg. As mb moves down, we want to determine the magnitude of the acceleration ma and mb, given that the angle theta is 34 degrees. We also want to find the smallest value of mu k that will keep the system from accelerating. Now, given that mb is moving down, ma must be moving up the incline. So the force of kinetic friction on ma will be directed down the incline. Since the blocks are tied together, they will have the same acceleration. We'll call this acceleration a, and we can write Newton's second law for each mass. So the sum of the forces in the y direction for b is equal to mb times g minus the tension in the chord Ft. And by Newton's second law, this must equal to the mass of b times the common acceleration a, which means that the tension force Ft must equal to mbg minus mba. If we take the forces in the x direction for a, this is equal to Ft minus ma g sine of theta minus the frictional force down the incline FFR, and this must equal to ma times the acceleration a. Similarly, for block A, if we take the sum of the forces in the y direction, we get this to be the normal force Fn minus ma times g cosine theta, and this must equal to 0, since there's no net motion in the y direction for block A, which means that the normal force Fn must equal to the component of the weight of A perpendicular to the plane, which is ma times g times cosine theta. Now, if we take the information from the two y equations and substitute into the x equation, we can solve for the acceleration. So we get mb times g minus mb times a minus ma times g sine theta minus mu k ma g cosine theta is equal to ma times a, which means that the acceleration a is equal to mb times g minus ma times g sine theta minus the coefficient of kinetic friction mu k times ma times g times the cosine of theta, all divided by ma plus mb. And so this simplifies as a half g into 1 minus sine theta minus mu k cosine theta. And so this is a half times 9.8 meters per square second into 1 minus the sine of 34 degrees minus the coefficient of kinetic friction is given as 0.15 times the cosine of 34 degrees, which gives us the acceleration of both blocks to be 1.6 meters per square second. Next, we want to find the coefficient of kinetic friction that will allow the system to be to not accelerate, rather. So to have an acceleration of 0, the expression for acceleration must be 0. So a is equal to a half g into 1 minus sine theta minus mu k cosine theta must equal to 0, which means if we rearrange, we can solve for the required coefficient of kinetic friction mu k. And we get mu k to be 1 minus sine theta divided by cosine theta, which is 1 minus the sine of 34 degrees divided by the cosine of 34 degrees. And so we get the required coefficient of kinetic friction to be 0.53.